Okay, hi guys. I hope you're doing well. So I realized that on my first part of the word problems video that I did not actually show you guys the first problem. Like the question was not in the frame, so I'm very sorry about that. But let's just move on to the third problem. As you can see, I've already done work on this 2 different ways. I've just been having some editing problems, but that's fine. I'm just going to explain you the 2 different ways that you can think about the third problem, and then in the next video, we'll go to the next problem. I want to try and do just one problem at a time so these videos aren't too long, okay? So for number 3, it says that David runs 5 miles per hour. He runs twice as fast as Marcus. How fast can Marcus run? Okay, so after reading this, sometimes on your first try reading it, you're kind of like, oh, I still don't get this. That's okay. It's okay to read the question more than once, okay? If you read the question more than once, it will most likely help you because you might see some little details that you may have missed if you only read it once and tried to do the math. So we'll read it again and we'll kind of paraphrase it more, okay? So what we know is that David runs 5 miles per hour, right? And so I wrote this down. The D is for David, okay? So David can run 5 miles per hour. Well, per hour, if I have a per here, P-E-R, then what I need to do is I need to draw a fraction bar, and then for however much time or whatever the next word is after the per, I need to put as my denominator, okay? So saying 5 miles per hour is another way of saying 5 miles for every hour, or 5 miles for 1 hour, okay? That's why I have that 1 hour there. But you don't always need that number 1, so you can also write it as 5 miles just per hour, okay? Per is that whole division or fraction bar, okay? Then it says he being David, runs twice as fast as Marcus. Okay, well, twice as fast is the same thing as saying 2 times as fast, but that just kind of sounds weird, so that's why I wrote it down as twice as fast, okay? But twice is the same thing as 2 times, okay? As Marcus, okay? So we're comparing this to Marcus, okay? So if I think about this logically, if David runs twice as fast as Marcus, David is faster than Marcus, right? So if David is faster than Marcus, he can run more miles for every hour than Marcus can. So logically speaking, your answer should be less than 5 miles per hour if we know that Marcus is slower and David is faster, okay? So now the question is asking us, how fast can Marcus run? Okay, well, we know, just thinking about this logically, without doing any math, that the answer is going to be less than 5 miles per hour because David runs faster. How much? He runs twice as fast, okay? So here, this is what happens when we think about it logically, which I don't expect elementary school students to know this because this is kind of a convoluted and confusing way, but I'm going to try and explain it multiple different ways. So I have M for Marcus here, okay? Why do I have 5 over 2? Well, what this means is that for Marcus to cover the same amount of ground as David, which is 5 miles, for Marcus to get that same distance, it's not going to take him 1 hour. Okay, that takes David 1 hour. It's going to take Marcus 2 times as much time, or twice the amount of time, to cover the distance that David has, okay? So that's why I have 2 hours here instead of 1. Because what's 1 times 2, right, from this twice as fast? 1 times 2 is 2, okay? So then this becomes a division problem, and then we could do 5 divided by 2, and this is where the long division is. So you would have your divisor of 2 on the outside, and your dividend of 5 on the inside of this little division tent. And then you can ask yourself, well, how many times does 2 go into 5? You'd say 2 times. Why? Because 2 times 2 is 4. And then what's 5 minus 4? That would be 1. And then I get that 0 from dropping this 0 down. Now, why did I do that? Because I anticipated that, hey, this answer or quotient might have some decimals, okay? So that's why I always make sure I put a decimal point after the whole number, just in case we get some division that doesn't lead to just a whole number, okay? So now I'm left with 10. Well, 2 goes into 10 5 times because 2 times 5 is 10. And then what's 10 minus 10? Well, that's 0. So once I get to the 0 and I see that everything's been covered, I can stop that division and just say that my quotient is going to be 2.5. Well, 2.5 what? 2.5 miles per hour, right? Because we always want to keep our units, okay? So that's one way of explaining it. The other way, which I like to explain it better because it's more mathematical in terms of creating something into an equation. So here in blue I have D equals 2 times M. Well, what the heck does that mean? D is David, right? David can run twice as fast as Marcus. This is a translation in, if your language was math, this would be the translation from David runs twice as fast as Marcus, okay? In math terms, that is D, David, equals 2 times M, or Marcus, okay? So now, if we have this equation here, what we need to do is we need to solve for M. Well, why? We already know the value for David in terms of his speed. It's 5 miles per hour, right? So I can just plug that in, 5 miles per hour for David, which I did down here, okay? So now I have 5 miles per hour equals 2 times M. Again, why are we doing 2 times M? This 2 times M corresponds to the twice as fast as Marcus, okay? So Marcus goes there. Twice as fast is the same thing as 2 times, okay? Now what are we comparing that to? We're saying that David is the one who runs twice as fast as Marcus, so that's why we have D on the other side. Okay, now our main thing is we want to get M by itself because M is our unknown variable. And what are we trying to figure out? How fast can Marcus run, right? So we want to solve that M to figure out how fast Marcus can run. So to do that, I need to get rid of this 2 to isolate this variable, okay? When I say isolate the variable, I just mean get this unknown variable, which is M, alone. And by alone, I mean getting it to have it so that there aren't any numbers or any variables on the same side of the equation, okay? So to do that, I need to undo some operations. So what is holding 2 and M together? Well, that is multiplication right here. Well, how do I undo multiplication? Well, I need to do the opposite of multiplication, which is division, right? So that's why I divided both sides by 2. Okay, this fraction bar is the same thing as dividing by 2. Okay, now what I do to one side, I must do to the other side, okay? And why did I change this 5 miles per hour to 5? Because I just wanted to focus on numbers, okay? So if I divide both sides by 2, I get 2 divided by 2, and remember, 2 divided by 2, anything divided by itself is 1, okay? So if I just have 1M, that's the same thing as M, okay? Now I have 5 divided by 2, or 5 over 2 is the same thing as 5 divided by 2. I did the long division, like how I explained here, and I got 2.5. Now remember, division and multiplication are opposite. So if I'm asking you what's 5 divided by 2, essentially I'm asking you 2 times what number gives me 5, okay? And we find out that that answer, or that quotient, is 2.5. Okay, so we can say that Marcus runs 2.5 miles per hour, okay? So in the next video, we're gonna focus on a different type of word problem. It's gonna be a little lengthier, but it'll be okay. My advice for you guys this video is it's never too late to ask for help. I think last time I talked about it was never too late to try or like change, you know, your attitude around or whatever, but my main point here is that it's never too late to ask for help. If you have good and compassionate teachers, they will want you to ask for help, okay? They shouldn't be discouraging you. They should just encourage you to ask for help because it shows that you're listening and you're paying attention and that you want to do better. And that's what all teachers and educators want from you guys, okay? So keep up the good work, and I will be back with another video very soon. Okay, bye guys.